Yes, apologies. It's the Mark and Mark show today. So we've got Mark McFadden, who I think you probably all know quite well, and I'm Mark Robertshaw. So Mark will set us off.
So I love being the surprise guest. That's great. I want to do my part very quickly so that we get to the architecture and interesting stuff. The DNS Research Federation is a UK nonprofit that is really devoted to doing research on the DNS in a variety of areas, not just technical areas. And my particular interest is in the security of the DNS. But the work that the Federation is doing is very broad. It's trying to do data collection and improve access to data. It's trying to do education and outreach to people. A big part of the work that it does is research. And of course, after the last presentation, engagement in technical standards, the work that's getting done, for instance, in DNS-OP and in other places like that. So that's what the DNS Research Federation does. The motivation here is really something that we've heard about all day, I think. There's a lot of interest in sort of measuring the capabilities of resolvers in the wild. This is work that Jeff had done for a long time, years ago. And what we wanted to do was try to stand on the shoulders of a giant and try to improve upon that work and maybe make it a little more modular and also make the data public. Those were the two ideas that we had. So that's the motivation. The overview here is to actually build an open source testing framework. Basically, what we're going to do is actually build a set of modular tools that we can use to do testing and then have an architecture, which Mark is going to tell you about, that actually allows you to deploy open source DNS and web servers to actually collect information about how resolvers work. That's fundamentally what's going on here. It also, because the work is open source, it also allows organizations to go ahead and do that testing privately. So if an organization wants to take a look at resolver capabilities but doesn't want to make the data public or doesn't want the testing to be public, you can do that with your own customer base. And that was one of our explicit goals here. For us in the DNS Research Federation, one of the things we're really interested in is collecting more data and sharing that data so that we can do more analytics. Much of the presentations that we saw during the day today talks about resolver behavior, and we think the more information there is available about resolver behavior, the better that is. The way that this works is actually really interesting, so you should have someone useful talk about it.
Brilliant, thank you, Mark. So, as mentioned in the previous slide, this was commissioned by the ICANN OCTO team, initially as an open source tool. And the scope for the first round was to produce these 6 out-of-the-box tests, which were made available for testing resolver capabilities. Very pleasingly to me, many of these have been discussed in detail today, so I don't have to elaborate too much. Obviously, IPv6 transport we've spoken about this morning. Q&A minimization has been touched on. Aggressive NSEC, I like to call it the piggy in the middle test, for those that get that one. Obviously, TTL tests as well, quite maybe slightly less relevant these days, but still useful. And the TCP fallback we've dwelt on a lot today as well. So, and DNS-SEC validation is a little bit of a sort of minimized in that description there because it's actually a suite of tests that looks more at the different sort of combinations of DNS-SEC validations that are possible. So, as well as testing any algorithm and any key strength that goes along with each algorithm, it's also about looking at the different combinations of validated at the delegation level, but not validated at the zone level, and vice versa, and looking at the interactions there as well. So that's the scope for the sort of first round of this tool. The point to make really is that we designed this to be extensible. So rather than just thinking about 6 tests explicitly, we've designed it to be eventually able for customization in a very easy manner, so that users can not only use this system with the built-in stuff that's there, but also very easy and rapidly extend it for their own uses and define their own tests. So here's the architecture summary. I mean, a picture's always worth 1,000 words, so it's best to start here. So in the middle of this diagram, we see what we've determined as being a test bed. That's really a configured server, which could well sit within an organization's own management, and it's configured using a toolkit we'll talk about in a minute. That houses really the authoritative DNS server that's being configured here, and we use Bind for that at the moment, commodity server, and also a web server, which will become clear as to why that's useful as well. Then on the left-hand side, you can see that the way that we're triggering the tests is via requests generated on websites. So effectively, you're making a web request, which implicitly generates obviously DNS A or quad A requests to the configured resolver at the top, which then causes those to be sent to the test bed. So effectively, on that single server, we're collecting both all the DNS traffic coming from requests being generated, but also, as a nice side effect, also information about the clients which are calling that directly as well. Just to mention on the right-hand side, one of our big incentives as an organisation for doing this project is that one of the components we already have in existence is a analytics platform called DAP.live. And we see that very much as a thing we can offer to people who use this as a ready-to-go analytics system, which will augment the analysis being performed on the test bed, with other data we have in the platform. So the two key components, as we've mentioned already, there are two basic sides to this. There's what we call the server side, which is the bit in the middle of the diagram shown before. That has essentially two things. It has a CLI tool, which is used for configuring. And I think it's worth mentioning at this point that the intention here is for it to be a sort of fully managed process. So it's not expected that whilst in this room we've got experts in configuring all the components who can do that themselves, this is designed to do all the work for you. So the thought being that it would configure the authoritative server for you, it would configure the web server, and also issue Let's Encrypt certificates as well to make sure that you can make secure requests from websites typically required in today's day and age. So that's the sort of that side of things on that side. As mentioned, we've used Bind and Apache to start with, the idea being that it's very commodity, very easy to install on lots of a range of servers. We're not at this stage looking at customized DNS servers, but and using very much stuff that's already out there. So on the client side of things, we've got a client-side website toolkit. This is designed with a standard JavaScript library, very easy to install on websites, and works very much in the background. So we'll look at those in a little bit more detail now. So moving to the server side, this is the middle bit here, as we discussed. There's two basic things that are happening on the server. You've got a CLI, as mentioned, for management. That will configure the various servers with the test domains. The bit you need to do yourself really is just simply register the domain and do the delegated bit at the registrar. Everything else is pretty much done for you within a test bed for a given test that's being configured. The other side of it is that the CLI provides access to the logs, and you can get logs in standard CSV format, JSON or JSON-L if you prefer, in a very standard way. And the other important aspect of this is the actual logging itself. And of course, to get this to work well, we've needed to intercept the logging on both the Bind and the Apache side. And we've chosen to do that in a fairly rational way to centralize the logs so we can then produce combined logs in a very rational manner and report on that. And as mentioned, we support for ourselves, send them straight to our own platform to give access to a very visual and very analytical way of working with that data directly. Just to mention that whilst not necessary for the first phase, we have chosen to make the architecture extensible from the word go. So test types are defined using a standard JSON schema. And you can see the kind of thing, the example on the right here gives you a flavor for that. But effectively, you can build tests by defining the records that you need for a given test. You can define what you want to happen at the web server side as well. And obviously, any level of that is possible. And the idea eventually is that user-defined test types will be installable just as simply as JSON files. So not only can you tweak and configure the built-in ones that are available, but you can also write your own from scratch. And it's anticipated in the next phase of development that we'll be providing validation for that to make that process much more straightforward. So in terms of the logging side of things, we go for a very wide view, and we aim to incorporate everything that you would need for a given test in a single record hit. So that would incorporate any of the expected DNS hits. So take, for example, QNAME minimization, you might well expect to see perhaps 4 DNS hits there if it's minimizing. We're going up the chain. If you had like a 4-level subdomain, we'd record all of those DNS records as part of a single row for convenience, as well as any HTTP logs as well. And we have a Boolean indication of a true, a pass or fail for a test. We do appreciate and will clarify at this point that not all tests are binary, and it's helpful to have a pass-fail, but we also have the flexibility and analytically certainly to work with tri-states and quad states and all sorts of different types of states for tests if required. And a really important point to make, just in today's climate, is that logging level can be adjusted. So the default for our system is to actually log at the /24 or /48 in IPv6 level, as opposed to logging end user IPs directly, and that's our policy at the moment. But you can configure that if you wish to, for yourself, go deeper. You can do that. So moving on to the client side, which is the web side of things. Over there. As mentioned, it's installed as a standard ES6 JavaScript library on the testing website. And this works by triggering tests using background AJAX requests. So it's very much like Google Analytics or something like that. It's very transparent to the user, and it effectively interacts with the test domains that are being configured on the server side and makes the calls accordingly. In much the same way as the server side, the intention is that if you write your own test, you can likewise write your own extension using a very simple JavaScript API to trigger custom tests or sequences. So, for example, if you were doing a TTL test, you might need to trigger 2 requests with a sort of sleep between them. So that's all very configurable at the JavaScript level as well. Okay. So apologies, we were going to do a live demo at this point, but it's proved to be too tricky to make that work. So very happy to talk more with people about or show people some of the stuff offline if people would like to see more of the actual workings of this. But just to sort of finish this presentation at this point, we'd love people to get involved with this. The main thing at this stage is it's very much hot off the press. It's literally been sort of rolled out and is currently still being evaluated by ICANN at this point. So we'd love to get beta testers on board. That could be one of 2 different types of testers, really. You can do the full works and install the server on your own system. You can install the JavaScript on your own website and test it for us, and we'd love that to get feedback on how that works for you in the wild using that. Secondly, we'd love it if you were willing to share some data back to us as an organisation. As Mark mentioned at the beginning, we are a research organisation. We're committed to enhancing knowledge of the internet at large and the DNS system, and we'd love to be in a position where over time we can start to gather real-world global stats, much like Jeff's done over the years in a more consolidated way. So we'd love it if people are willing to, as well as use this for themselves, which is one of the core offerings, also be willing to share. And just to say that there's also we have some capacity for offering support and development within the context of this project. So if people are interested in using this and would like us to provide some support in doing that, we'd be very happy to talk to you about how we could support you with that. And finally, my apologies, there's no links on this page, but I will post some links in Mattermost after I finish the discussion here to both our GitHub project and to the hot of the press documentation site, which is fairly comprehensive now. But I'd be very happy to take any questions at this point. Thank you.
So you said this works by parsing logs from Bind and Apache. Could you say more about what kind of logs you're talking about? Are these logs, what format are they in? Are they considered a stable API?
We've implemented effectively a custom logging system in Bind to capture the raw logs coming in. As a result, we hit the thing, we capture logs that would come in to Bind and log those ourselves in a database system on our side. And Apache-wise, it's somewhat easier because you can just intercept the standard Apache logs, the common logs that be written out normally to a file on the server.
Okay, thanks. Yeah, I'd like to understand if that's actually a stable API that you're relying on, or whether that's an implementation detail that the Apache people can change their indentation and break your parser.
Yeah, that's a fair comment, and we can talk about that more if you like. Yeah.
And also, have you thought about a headless version of this for automated testing? Right now, this seems like this is something that runs in an actual browser over an actual network through an unidentified resolver. What if could I use this to spin up a resolver in a Docker container and throw a battery of tests at it to see what it does?
I think absolutely. I mean, the incentive here is to, I guess, provide entities primarily with the ability to test their customer base. So you'd be expecting them to put it on a public website for that purpose. But there's no reason why you couldn't install it, especially given the fact it uses commodity JavaScript. You could use Chrome headless, for example, and it would work equally well. Yep, definitely.
Hi, I'm Alison Mankin from Packet Clearinghouse. And my question is, right now there's quite a few programs that are about kind of the public offering of different kinds of DNS infrastructure. Think about NIS2 or something like that. Is there an element where you would run tests which were not as client controlled, where there would be some kind of comparative capabilities between clients for a third party?
Yeah, I mean, I don't see why not. And actually, one of the things we've built into this is the ability to heavily customize the tests that you run. So doing things such as A/B testing with different sort of client bases, I think, would be very possible through this mechanism. And what we allow effectively is usually a one domain per test model that we use, but so you can have map as many different domains for different purposes to the platform for different types of testing. So I think you'd be able to do exactly as you describe with that.
Thank you.
Thank you. Anything else? I think you all want your dinner, don't you, now, because it's the end of the day. But thank you.